going to focus on the mid-latitude cyclone, on the cross section of mid-latitude cyclone. So do not forget to like, subscribe, and share this video. So let's start. In our previous segment of videos, we dealt with the stages of formation or stages of development. Now you must know this cross section where they might ask you to actually draw it. So you must give this labeling. The general direction is west to east or easterly. We've already dealt with that in the characteristics of mid-latitude cyclone. Then this is your cold front, and it is steep. And your home front, it is gentle and resulted in nimbo stratus, whereby your cold front result in your cumulonimbus clouds, and this is your warm sector, Then cold air moves under the warm air. Then warm air rising above the cold air, and cold dense air moving away. Yeah, so basically what we need to know on this cross section, we must know the weather associated with this cold 1 and 2 and warm front, cold front and warm front. So we must know that our country, South Africa, is mostly affected by the cold front. So let's see the weather associated with this cold front. Cold temperatures, low pressure, overcast condition, cumulonimbus, and results in thunderstorms. This is what you must know. You must know that temperature, when the temperatures are high, it means the pressure must be low, and humidity must be high. When temperature increases, pressure will decrease, the pressure and humidity will increase. This is what the general knowledge you must know about the weather elements. So because here we on the cold front we have what we call low temperatures. The temperature is low, it's cool, so meaning that it result in a higher pressure. So let's look weather behind the cold front, rather behind the cold front. So cold temperatures, high pressure, partly cloudy, and cumulonimbus cloud and rain, higher rainfall. Yeah. So we must check this cross section here. I want us to look at this part, whether associated with the passage of mid-latitude cyclone. They might ask this question for you to give the evidence that the mid-latitude cyclone has passed. So we must know that in winter, mid-latitude cyclone migrate. This is very much important. In winter, the mid-latitude cyclone migrate the northward, thus moving greater impact in the land. And in summer, however, they migrate southward and have a little impact on the weather on the land. This means that when we have the cross section of our country, if it's winter, the cold front will shift northward because they move with the apparent movement of the sun, and the ITCZ is shifted upward, causing the front to move in the land. That's why we find the Kalahari pressure on the land. Then in winter, the cold fronts move southward, then just because of the low pressure in the interior, and your ITCZ is shifted downward, causing the front to move down southward. Home front generally have little impact. They might ask this question. This is very much important. Warm front have generally little effect on South Africa because it moves far from the country. Then when South Atlantic high ridge is behind the cold, more old air brought through result in a heavy shower. It's not. I wanted us to look at this part. We also need to know the changes in direction of the wind of mid-latitude cyclone. On the left is anticyclone and it's called baking. Changes in right, it's cyclone in the clockwise. It's veering. So I want to show you something here. The air backs is a baking of air. And veering of air in the north. So the air is baking on the southern hemisphere and air is veering on the northern hemisphere direction. So You need also to know the condition and the weather elements when the mid-latitude cyclone or cold front approaches. So when cold front approaches the land, this is our land. When cold front approaches, temperature does what? Drops. Then the airbags, air pressure, I'll say it increases. Deep pressure, then humidity, it decreases. Then precipitation is thunderstorms. And also when warm front approaches, let's say this is our land. When warm front approaches, the temperature increases. The temperature increases, then the pressure decreases. The pressure decreases and humidity increases. Humidity goes with the temperature, they are directly proportional. When temperature increases, humidity increase, then pressure will decrease. Yeah, this is the end of our video. Don't forget to like, subscribe, and share, and comment. In our next segment, we'll focus on the impact of mid-latitude cyclone. Then we end with this chapter of mid-latitude cyclone.